Hello everyone, myself Nimesh Prabhakar. Welcome to Automotive Electronics lecture series. In my previous lecture, I have discussed about the anti-lock braking system, that means ABS, and we also discussed about the electronic suspension system. Now, in this lecture, we will discuss about the power steering. Then, next one topic we discussed is the four-wheel steering, and last we discussed about the onboard diagnostic, that is OBD. So we start with the first one, power steering. So this is the figure of the power steering. So what is the main purpose of the power steering, or we can say why we use the power steering system in the car or in the automobile? So the purpose behind this, that means the power steering is a system that reduces the effort required of the driver to turn the steering wheel. So by using this system, the driver have to use less effort to turn the vehicle. Without power steering, or we can say without power assist, the steering of the most vehicle would be extremely heavy, particularly during the low speed, such as pulling into the parking spot or turning a 90-degree corner in the city, or we can say in the crowded gas station. So at that time, the driver have to apply more effort to control the steering or to turn the steering. So by using the power steering system, the driver has to apply low effort or low strength to turn the wheel. Now we discuss about the hydraulic power steering. So the hydraulic power steering used, as its name indicates, the hydraulic fluid that is pressurized by a pump driven of the engine. So here we use the hydraulic pressure to operate the steering. Now the disadvantage of this system we discuss here. So there is a waste energy since the pump is running continuously even when the vehicle is driving straight and there is no assist need. So this is the first one disadvantage of hydraulic power steering system. That means the pump that we use to control the steering system is continuously running. If the driver is not turned the vehicle, still it is in the running position. And the second one is the hydraulic fluid need to be replaced periodically, and if any of the hydraulic lines spring a leak, it not only make a mess, but the power assist is lost. So this is the second one disadvantage. That means we have to change the hydraulic fluid that we use to control as time to time. That means there is a limitation like a 6 month or after 12 months we have to change the fluid. So these are the disadvantages of hydraulic power steering system. So this disadvantage can be solved by using electronic steering control system. So instead of the hydraulic control system, here we use the controlling by help of the electronics. So the advantage of this system we discussed here. This system have variable power assist, which provide more assistance at the lower vehicle speed and less assistance at higher speed. That means its change is assistance for according to the speed change. That means at the lower speed and at the higher speed, this assistance is also changed. They do not require any significant power to operate when no steering assistance is required. For this reason, they are more energy efficient than hydraulic system. So these are the advantages of the electronic steering control system. Now we understand the block diagram or working of this electronic steering control. The EPS electronic control unit, we can also say the ECU, calculate the assisting power need based on the torque being applied to the steering wheel by the driver, the steering wheel position and the vehicle speed. Then the EPS motor rotates a steering gear with an applied force that reduces the torque required for the driver. Now we discuss the second one topic is the four-wheel steering system. So what is the four-wheel steering system? First one question occur in the mind. So here the steering control normally in the normal car is connected with the front two wheel of the car. In the rear wheel there is no connection, it's attached with the steering. But in the four-wheel steering system, we control the four wheel, that is each wheel by help of the steering. That means the wheel is attached to the steering system. Four-wheel steering is a method developed in the automobile industry for the effective turning of the vehicle. In a typical front wheel steering system, that means in normal system, normal car, we use the steering is attached with the rear wheel, in the front wheel. The rear wheel do not turn in the direction of the curve and thus a curb on the efficiency of the steering. In the four-wheel steering, the rear wheel turn with the front wheel, thus increase the efficiency of the vehicle. The direction of steering the rear wheel relative to the front wheel depend on the operating condition. Like at the low speed, wheel movement is pronounced so that rear wheels are stepped in the opposite direction to that of the front wheel. So this is the first one condition. When the vehicle speed is at the low speed, so at that time the rear wheel, that means the backside wheel, are stepped in the opposite direction to that of the front wheel. That means if the front wheel is in the left side, then the rear wheel is the movement is in the right side. Now the second one, it is at the high speed. High speed, when the steering adjustment are subtle, the front wheel and the rear wheel turn in the same direction. So at the high speed, the direction of the turning of the wheel is in the same direction. So this is the working of the four-wheel steering system. So it is divided according to the speed. Like at the low speed, both the front and rear wheel is moved in the opposite direction, and at the high speed, both front and rear wheel is moved in the same direction. Now we discuss about the advantages of four-wheel steering system. So first one advantage is superior cornering stability. So what do we understand here? The vehicle cornering behavior becomes more stable and controllable at high speed as well as on wet, slippery road surface. Now second one advantage is improved steering response and precision. The vehicle response to steering input become quicker and more precise throughout the vehicle entire speed range. Now the third one advantage is high speed straight line stability. That means the vehicle's straight line stability at high speed is improved. Negative effect of road irregularities and crosswind on the vehicle stability are minimized. Then the next one is improve rapid lane changing. That means this stability is lane changing at high speed is improved. In a high speed type operation become easier. The vehicle is less likely to go into the spin even in the situation in which the driver must make a sudden and relatively large change of the direction. So it provides the more stability when driver change the lane or rapidly change the lane. Now next one advantage is smaller turning radius. So it is a very good it is a very beneficial when we have to turn car in a very small space. By steering the rear wheel in the direction opposite the front wheel at low speed, the vehicle turning circle is greatly reduced. Therefore, vehicle maneuvering on narrow road and during parking become easier. And last one is the controlling. The control quarter step can be switched on and off and has been an effective trailer towing mode. Now we discuss about the disadvantages of this four-wheel steering system. So the first one is the four-wheel steering system. Due to the construction of the many new components, the system becomes more expensive. So it increases the cost of the car. And the second one, the system includes as many components as is required. There is always a chance to get any of the part inactive, thus the system becomes inoperative. So these are the disadvantages of four-wheel steering system. Now we discuss the third one point is onboard diagnostic, and it is known as the OBD. So first we understand what is OBD, or we can say onboard diagnostic. Onboard diagnostic, as the name suggests, refer to the in-vehicle system that detect and report the status of vehicle health. With the help of OBD port and OBD connector, the repair technician or after-sale service provider get access to critical vehicle parameters like vehicle speed, engine data, emission data, and more in the form of diagnostic trouble code, that is DTC. Now, where is the OBD2 port is located? So this OBD port is here. We can see this figure is located. So in a typical passenger vehicle, you can find the OBD port on underside of the dashboard on the driver's side of the car. That means here we can see that this is the OBD port. Depending on the type of the vehicle, the port could have a 16-pin, 6-pin or 9-pin configuration. So this is the block diagram of the OBD control system. So here the ECU, that is the electronics control unit, is the main heart of this system, and it is connected with the sensor, actuator, and DLC and MIF. So how does OBD work? We discuss here. So the OBD system consists of the following component. First one is the ECU, then sensors, then DTC, then MIF, and DLC. So now we discuss one by one. So first one is the ECU. The central part of the OBD system is the electronic control unit. The ECU collects input from the various sensors throughout the vehicle. The ECU then uses this data to either control part of the vehicle like a fuel injector or monitor for the ECU. So ECU is collect the data by the sensor and it operate the actuators like the fuel injector. Now the sensors. The sensor send a code of the ECU specifying the source and the parameter of the signal. The ECU then read and interpret this signal. Then next one is the DTC. If the sensor send information to the ECU that fall outside of the normal range, the ECU save the information as the code, and this code is called diagnostic rubber code. The DTC code essentially is a list of letters and the number which indicate the source and the nature of the problem. So there are the different codes for the according to the different manufacturer of the vehicle. So this code is very helpful for the diagnostic purpose. And last one is the MIL. So when the ECU collect the DTC code, that means the fault code, it sends a signal to the vehicle dashboard to turn on the appropriate indicator light. So sometimes we can see the lights on our dashboard. This light, known formally as the malfunction indicator light or MIL, provide an early warning system for the vehicle malfunction. And last is the DLC. So all of the data and the DTC code collected by the ECU can be accessed via the diagnostic link connector or the DLC. So by using the DLC connector or diagnostic connector, we know that OBD2 connector, the data is collected. So this is the operation of the OBD onboard diagnostic tool. So in this lecture, we have discussed first one about the power steering, then we have discussed about the four-wheel steering, and last we have discussed about the OBD onboard diagnostic system. So in this lecture, we have discussed about this topic. Thank you. Hello and welcome to our channel Electronics and Communication Engineering. Congratulations to find us for learning. You are watching a lecture session on automotive electronics that has approximately 15 sessions and more are coming up. We have more than 1200 sessions in various lecture series on courses for electronics and communication engineering. Watch it and learn. If you like it, share it, subscribe it and press bell icon to receive all updates on new session. Enjoy learning.